All right, today we're graphing inequalities with two variables. When we do that, the first step you do is you graph the boundary, and you do that by solving for y and getting it into y equals mx plus b. Getting it into slope-intercept form allows you to graph the boundary. Then you use a solid line for when it's equal to, and you use a dashed line when it's not. When it's greater than or less than, you use a dashed line. That means the line is included when it's equal to. A solid line means the line's included. Use a dashed line when it's not. The second step is use a test point to determine which half plane should be shaded. You do not use a point on the line. Use a point somewhere on one side of the plane or the other. You do not use a point on the line. If it is correct, if the test point makes the inequality true, then that's the side you shade. If it's not, then you shade the other side. Any questions? So let's graph this. Our first step is to graph the boundary. So I have to get y by itself. So I subtract 3x to both sides. I have negative y is less than 2 minus 3x. I can't have a negative variable, so I make y positive. That changes that sign. That changes that sign. I do that by dividing by negative 1. And when I do that, I also have to change my sign because dividing by a negative number changes my sign. Don't forget that step. Okay, or you will shade the wrong side. The boundary will be right, but the side will be shaded wrong. Okay, so if you change the sign of something, you gotta change your inequality sign. Let's graph that. Negative 2 is my y-intercept. My slope is up 3 over 1. So I do that a couple times. Then I go backwards a couple times. Okay, now what you have to think is this a dashed line or a solid line? It is dashed because it's not equal to. Okay. Now I pick a test point somewhere not on the line that I can put. My favorite one is 0, 0. It's not on the line, so that's okay. I can use it. It makes things easier. Plug 0 in for x and 0 in for y. And see if it comes out true. 3 times 0 is 0. 0 minus 2 is negative 2. Is 0 greater than negative 2? Yes. So this is the side I shade.
So greater than is left.
No. 0, 0 makes this a true statement. So that side it must be true. Okay. Later on, okay, you might do the other side and it could be greater than. Okay. 0, 0 makes this a true statement. So that side is shaded. Okay. Let me pick a point on the other side. You don't have to do this, but let me pick a point on the other side just to prove to you that this comes out right. Let's go with 5, 0. Plug in 5 for x and 0 for y. 15 minus 2 is 13. Is 0 greater than 13? No. So that's why the right side is not shaded. Okay? The left side is. Because every point on the left side, not including a line, makes this a true statement. Alright? Write this down. X minus 1 is greater than y. Is y already by itself? Yes, so I can graph it. My y-intercept is at negative 1. My slope is 1 over 1. So I do that a few times in both directions. Is this a solid line or a dashed line? It is dashed because it's less than or greater than. Oh. If it's less than or equal to or greater than or equal to, that's the solid line. But it does not have a line under it, so it's not equal to it. It's a dashed line. Okay? Now, let's pick a point. What point you want to put in there? 0, 0. It's easy, right? 0 minus 1 is greater than 0. Is that a true statement? Is negative 1 greater than 0? No. So what side do I shade?
Right.
The right side, the other side.
So if it's like not true, you shade on the right side?
I shade on the other side.
Is that all we're doing is shading?
Yeah. Graphing inequalities and shading. Okay? Willie, let's say you picked 4, 0. Okay? On the right side. 4 minus 1 is that greater than 0?
Yeah.
So guess what side you shade? The right side.
So you have to use equation that has 0 in it?
No. I just like it because it's easier.
Why would you?
Let's go with 4, 1. Is 4, 1 on the right side? Yep. 4 minus 1, is that greater than 1? Is 3 greater than 1? Yeah. So it doesn't matter which point you pick, just know which side of the line it's on. Okay? And if it's true, you shade that side. If it's false, you shade the other side. Alright? Any questions? X plus 5y is less than or equal to 10. So I gotta get y by itself. So the first thing I'm gonna do is subtract x to both sides. 5y is less than, I like to put x first, so negative x plus 10. We're going to divide by 5. I divide both of these by 5. So y is less than or equal to negative 1/5 x plus 2. My y-intercept is at 2. The number by itself is y-intercept. My slope is down 1 over 5. And then I go backwards, I go up 1 over 5. Alright. Is this a solid line or a dashed line?
Solid.
Solid because it's equal to. Alright. Now I pick a number to plug in. What do I want to do?
0, 0.
Let's go 0, 0. Okay? Plug in 0 here and 0 here. What is negative 1/5 of 0? What's 0 plus 2? Is 0 less than or equal to 2?
Wait, yeah.
So this is a solid graph. Now, could I haven't talked about this, could I plug 0, 0 in for this side, for this equation, the top one that we start out with? Do you think it's going to matter? No. What is 0 plus 0?
0.
Is 0 less than or equal to 10? Yes, so this is the side of the graph. Okay? Everybody with me? So it doesn't matter if you use this equation or this equation. If you got this wrong, then you're going to be wrong anyway. So, all right. Any questions? Last one. I want you guys to do this one. X minus y is less than or equal to 3. I want to get y by itself, so I'm going to subtract x. Negative y is less than or equal to 3. Well, let's do negative x minus 3. Plus 3. Changing the sign of y. Also changes my inequality sign. So this is my boundary. Y is greater than or equal to x minus 3. Y is greater than or equal to x minus 3. So my y-intercept's at negative 3. My slope is 1 over 1. Okay, and it's a solid line because it's equal to. So there we go. What point you guys want to use? Okay, 0. Let's plug it into the original. Let's go up here to the original. What's 0 minus 0? Is 0 less than or equal to 3? So there you go. All right, here's your homework.